Welcome. In today's video, I will be showing you how we can observe network traffic through Wireshark using two VMs we created on Microsoft Azure. So we can go ahead and go into that right now. We'll go to resource groups and we'll create a new resource group. This resource group name will be called networkwatcher. And we can just go ahead and create that. We'll use the region East US 2. Create. Alright, so now that the resource group is created, we can go ahead and go into virtual machines and we can create our Windows VM. So go to create, click Azure Virtual Machine, and we'll be using the resource group that we just created. Excuse me. So we'll name this Windows VM. And we'll use the Windows 10 Pro image. Just make sure you have a minimum of 2 vCPUs and 8 GB of memory so the VM can run correctly and just fast enough. So we'll name this username lab user and a password that is with a capital, a special character, and a number. So we'll go to networking next, and in networking we're going to create a new virtual network called Lab VNet for both of our virtual machines to use so they can communicate amongst each other. Just do that just to make things cleaner, and then we could just go ahead and review and create. Validation passed, so we could just create this now. Alright, so we'll just wait for this deployment to finish. Because it's going to create the virtual network, and if we were to start up the new virtual machine and get it created, I'm positive that the VNet that we created won't show up until, so we'll just wait until that's done. Alright, so it was able to finally get created. For some reason, it just took way longer than expected. Usually it doesn't take that long. So now we'll go ahead and create the Linux VM. So we'll just put that in the network watcher resource group. And we'll name this Linux VM. We'll use Ubuntu Pro 24.04 LTS x64 Gen 2, and we'll use a minimum. We'll use the same size. Now set this to password, and we'll name it lab user as well, and use the same password that we used for the Windows virtual machine. Next, and then for the VM, sometimes it doesn't show up when it's created, so we might have to restart this. So we'll just press F5, restart it, and create the VM again. Alright, so network watcher, Linux VM. Yep. And then we'll do password, lab user. Next, networking, and we could see now that the lab VNet is here for us to use. We'll just choose this. Next, review and create. And we can go ahead and create this. All right. All right. So that created very quickly. So now we can go to the Windows VM, grab the public IP address because we'll be using that for RDP, and we can go ahead and paste that right in. So we're going to switch to different accounts and then type in the password and username and password that we created before. All right. So now we're in the Windows VM. We're just going to press no for all this stuff. Alright, now we see we're loaded in. So get onto Microsoft Edge. Some pop-ups are going to show up, so we'll just X out on all of those. Yes. And then we could type in Wireshark. This is the packet sniffing software that we'll be using today to observe all of our network traffic in between Linux and Windows. Alright, so now that the wizard's open, we don't really need this browser anymore. And we can click next, 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 install. Install. All right. Everything's good to go. So now that Wireshark's installed, we'll go ahead and run that. Alright, so we will be using the Ethernet setting to watch everything. And as you can see, there's a lot of data going on in between this right now. This is basically just all of the traffic that's going on in this virtual machine and all the data that's being sent. We could see that now. So we're going to filter for ICMP. And this is basically the protocol for ping. So now we're going to go to Windows PowerShell. And we're going to ping the IP address, the private IP address of our Linux VM. So if we type in ping, and then we'll go ahead and get the data of our Linux virtual machine's private IP address. We'll just go ahead and copy that so we don't have to. And then boom. Oh, wrong thing. I'm just going to type it in. All right. Just go ahead and move that so we can see. And as you can see, we have requests and replies coming in from the source, which is this is our private IP address on this Windows machine, and this is the private IP address of the Linux. So you can see that we're getting replies back and requests, reply, request, reply. So that means we're good in business. We're back in business. So we're just gonna ping the DNS server for Google just to observe the network traffic that's going on through Wireshark. As you can see, we're getting communication. That is good. Alright, so now we're going to do some work with network security groups within Microsoft Azure. So we're going to initiate a perpetual ping that will do a non-stop ping to the private IP address of the Linux VM. So if we just type in ping 10.0.0.5 5-T, it will initiate a perpetual ping. So this won't stop until we do something about it. So we'll go back into Microsoft Azure, and we'll be going to network settings, and we go down to rules right here, and we can create a port rule that'll deny access to the Linux VM. So if we do inbound port rule, and we got any source, any destination, and we'll choose ICMP v4. We'll set the priority to 290s, so it takes priority over anything that's here already, and we'll deny any custom inbound. So we'll create that security rule, and once it's created, we can go back into our VM, and slowly but surely we'll get a request timeout. The request timeout shows that our network security group rule went into effect. So if you just give it some time here, no response found. Oh, almost. I think we started to receive it. Yep, request timed out, no response found. That is good news. So now that we're getting that, we can go ahead and minimize this, and we'll delete this port rule so we can gain access back to our Linux VM. No response found, no response found. And in little time, we will gain communications back. So okay, so now we're getting replies back, and that's good. That means everything is working how it's supposed to, and then we could just press Control-C to stop all the madness. So you could see that 124 packets were sent, and we lost 14. We lost 14 from when this was going on. Alright, so now we're going to observe SSH traffic. That's secure shell. That's what Linux uses. And we could do that by filtering for SSH on Wireshark. And then we'll go back to Windows PowerShell, and we'll type in SSH, the username that we created for the Linux VM, at the private IP address of that machine. So as you can see, we're getting information from that, and they're asking. So we'll just say yes, and then we have to type in the password. The password won't show up because of security and encryption purposes, but if we type it in correctly, we should be in. And now you can see that we're in, so we'll just type in host name just to double check. And we are in the Linux VM. As you can see, all of this traffic is popping up now. So now that we have that, we observe the traffic through SSH, we can just casually exit, and we'll leave the Linux VM. Now we will be observing DHCP traffic. So just as before, we'll just type in DHCP, and we can run ipconfig renew. And when we do that, we'll renew our IP address, and they'll show us the traffic that went on through there. Now we could do something a little special, and we can go to Notepad. And if we go to Notepad, Notepad is synonymous with PowerShell. You can run scripts through Notepad. So we'll just type in some script commands. So we'll do ipconfig/release. If you do ipconfig/release, it'll release the IP address that we gave it, that the DHCP gave, because that's what DHCP does. It gives you an IP address if the machine doesn't already have one. It's a Windows protocol. So we'll just type in renew, and then we're gonna save this file as a bat. So we'll just do all files, and we'll just call this dhcp.bat. Oops, I didn't save it where I wanted to save it, because we have to go through the directory in PowerShell just to find it. So we're gonna put it somewhere we know where to find it. I'm just gonna call this that. Yeah, that's fine. So we'll just go to Windows. I like to put it in Windows Azure. And yeah, we'll just save it into this folder. So if we type in change directory, we'll put in the source of where we're going. So now we're in the Windows Azure directory folder, and we can type ls, and we'll see our dhcp2.bat ready to go. So if we type in /dhcp2, it should run the script that we made. So it'll disconnect you from the Windows server, but since we put in renew, it'll bring us back because it'll give us a new IP address to use. See? In just a few moments, we'll come back online. And boom, we're back. You could see that the script ran. So you had release, took away the IP address, but it gave it back. So now we're just going to filter for DNS traffic. And DNS is domain name system. That's what browsers use. That's what browsers use to be able to give names to IP addresses so that we can see it as regular human beings. Because when you search up something like google.com, it has an IP address behind it, but computers don't exactly work like that. So we'll just do NS lookup for Disney.com. You can see it popped up. You can see it popped up, and that's good. We'll just do another NS lookup for Google. And you can see we're getting responses in Wireshark For the last part, we'll just be filtering for RDP traffic. So instead of typing RDP, we could just type in the port number, and we'll filter for that. This is just the way that it's done through Wireshark to get that filter. So all this spam that's happening right now is basically communications that's happening on this virtual network, because this is remote desktop protocol. So it's basically just spamming data that we're receiving in real time. When I move this mouse, that's data being sent through Wireshark. Cool stuff. All right, so that concludes our lab today. Thank you so much for taking the time to look at this. We'll see you in the next lab.